I want to welcome you to Lecture 10, Unit 2, and in this lecture we're going to be talking about measures of precision. And my name is Jorge. So when we talk about measures of precision, we're going to be talking about what is the precision of a specific data point in relation to the rest of data points in a particular data set. And so the objective for this lesson is that we're going to identify the precision of a data value and data set. We're going to use various measures of precision such as percentiles, deciles, quartiles. We're also going to do z-scores in this lecture. So previously we spoke about the measures of central tendency and variation. So there are also measures of precision or location. And like I said before, they're used to locate the relative precision of a data value within a data set. And they can also be used to compare data values from different data sets, or to compare data values within the same data set. Or they can be used to determine outliers within the data set. We're going to be talking about outliers a little bit more towards the end of this lecture. And, so again, we're going to be talking about z-scores, percentiles, quartiles, and deciles. So the first thing is scoring a 100 in a biology exam the same as scoring a 100 on a math test? Well, sometimes direct comparison of raw scores is really not possible, since the exams might have different number of questions or different values. So even though it might seem like a 100 is the same on both exams, when we actually do some analyzing the scores, we might find out that they're actually not the same. So the first thing we're going to be talking about is standard scores. And so standard scores allows the comparison of relative standards similar to both can be made using a standard score. And the comparison uses the mean and the standard deviation from a particular data set. And this is what we call the z-score. So a z-score or standard score for a value is obtained by subtracting the mean from the value and then dividing by the standard deviation. So the formula is this. So z is equal to the value minus the mean divided by standard deviation. For samples, it would be mean x minus x bar divided by s, and for population, it would be x minus mu divided by sigma. Now, for the purposes of this section, we're going to assume that when we find a z-score, the data were obtained from a sample. So here's the first thing we're going to do. So test score. So a student scored a 65 on a math test with a mean of 50 and a standard deviation of 10. Now the same student scored a 30 on a science test with a mean of 25 and a standard deviation of 5. So we're going to go ahead and compare his relative precision on the two tests. So immediately you might say, well, the 65 is a better score, but you'll actually be safer if we find the z-score for each one. So let's go ahead and do that. So the z-score for the math test and the z-score for the science test. So for the first one, we go ahead and do 65, which is the data point, minus 50, which is the mean, divided by 10, which is the sample standard deviation, and we get 1.5. So the z-score for the math test was a 1.5. Now the z-score for the science test was 30 minus 25 divided by 5, and that was a 1. So since the z-score for the math test is larger, his relative precision in the math class is higher than his relative precision in the science class. Now, since the z-score was positive, that means that the raw score was above the mean. If the z-score is 0, then that means that the raw score is the same as the mean. And if it's negative, that means that the raw score is actually below the mean. Now, when all of the data for a variable are transformed into z-scores, then the resulting distribution will have a mean of 0 and a standard deviation of 1. So then a z-score, what it actually measures is the number of standard deviations the value is from the mean for that particular distribution. All right, so the next thing we're going to talk about is percentiles. So percentiles are precision measures, and they're used mainly in educational and health-related fields to indicate the precision of an individual in a particular group. Now, percentiles divide the data set into 100 equal parts. The median is the 50th percentile. Now, several things. Percentiles are not the same as percentages. So if a student gets 65 questions correct out of a possible 100, she obtains a percentage score of 65, but that's not the same as percentile. There's no indication of her precision with respect to the rest of the class. So percentiles are symbolized by a capital P and a subscript 1 or 2 or 3 all the way to 99. And then percentile graphs use the same values as the cumulative frequency graphs that we did previously. And this is just an example of a percentile graph. So how do we find percentiles? So the first thing is that we're going to find the cumulative frequency and then place them in column C, and I do have a table coming up. And then we're going to find the cumulative percentages and place them in the column D, and then we're going to use the following formula. So cumulative percentage is equal to the cumulative frequency divided by n times 100, and then we'll go ahead and graph the data. So here's an example. So this is the frequency distribution for systolic blood pressure readings in millimeter of mercury of 200 randomly selected college students. So we're going to go ahead and construct the percentile graph. So we see that column A has our class boundaries, column B has our frequency. So the next thing is we're going to do is we're going to do the cumulative frequency and then the cumulative percent. So cumulative frequency is 24, 86. Of course, you know that you add the first two cells and 158 and so on all the way up to 200. And in the cumulative frequency, we use the formula to get that percentage. And then we use that column to graph and get our percentile graph. So the next thing we're going to talk about is percentile formula. So the percentile formula. The percentile formula is corresponding to a given value x is computed using the following formula. So percentile is equal to the number of values below x plus 0.5 divided by the total number of values times 100. So this is what it looks like. So a teacher gives a 20-point test to 10 students. The scores are shown here, and then find the percentile rank of a score of 12. So here we have the scores, right? So we have 18, 15, 12, 6, 8, 2, 3, 5, 20, and 10. So what is the percentile rank of a score of 12? So what we do is arrange them from smallest to largest, and that's what we did. Here's our raw scores. Then we're going to go ahead and substitute into the formula. So percentile is equal to 6 plus 0.05 divided by 10 times 100. So it's actually the 65th percentile. So the student that scored a 12 did better than 65% of the class. So what happened? Well, if we count them, 1, 2, 3, 4, 5, 6, there's 6 values below the one that we're looking at, which is the 12. So that's where the 6 comes from. And then, of course, the total number is 10, and we divide that, add the top divided by 10 times 100, so it's the 65th percentile. So test scores. Now, using the scores, find the value corresponding to the 25th percentile. So again, we arrange the data from the lowest to the largest, and then we go ahead and use the following formula to compute. So C is equal to n times P times 100. Well, n is the total number of values, and P is the percentile. So we're looking for the value that gives us the 25th percentile. So here we have it. So 10 times 25, which is the percentile, 10 is the number, divided by 100 is 2.5. Again, n is total number of values, percentile is 25. Now, if C is not a whole number, then we round up. So then C equals 3. So then for the 25th percentile, what we do is we find the value in the third position, and that gives us 5. Here's another example. Using the scores, again, that the test scores, find the value corresponding to the 60th percentile. So we use the formula again, and we get 6. Now, since C is a whole number, then we find the mean of C and C plus 1. So the 6th value is 10, the 7th value is 12, so then 11. So a score of 11 corresponds to the 60th percentile. Okay, so let's go ahead and talk about quartiles and deciles. Quartiles divide the distribution into 4 groups, separated by Q1, Q2, and Q3. Q1 is the 25th percentile, Q2 is the 50th percentile or the median, and Q3 is the 75th percentile. So as you can see, if we have a data set, we divide a data set into 4 parts. So how do we do that? So finding the data values corresponding to Q1, Q3, Q2, and Q3. So arrange the data in order from the lowest to the highest. Find the median of the data values, which is Q2. Find the median of the data values that fall below Q2. And then find the median of the data values that fall above Q2. And so here we have, so we're going to find Q1, 2, and 3 for the following data set. So the data set that we have is here. So we arrange the data set in order from the lowest to the largest. And then the first thing is we find Q2, and that's the easiest thing to do. And Q2 would just be 14, and that's our median. So the median for this data set is 14. So now what we're going to do is find the median for the data values that are less than 14. So what happens is that we look at this data value here, or the data set. 14 falls right here. So the median divides this data set into two equal parts. So then what we do is we're going to look at the lower half, and we're going to find the median of the lower half. Now the median of the data values that are less than 14 would be the median of the data points of 5, 6, 12, and 13. And in this case, it's 6 plus 12 divided by 2, and that's going to give us our Q1. So our Q1 is 9. Again, our Q2, our median was 14. So now we do the same thing for our Q3. So if you remember, we arranged them. So now the upper half is 15, 18, 22, and 50. So we find a median of that half of the data set. So Q1 is 9, Q2 the median is 14, and Q3 is 20. Now, quartiles can be a rough measurement of how variable a data set is. So the next thing we're going to talk about is the interquartile range, or IQR. And IQR is defined as the difference between Q1 and Q3. And this is the range of the middle 50% of the data. So what you do is that you deciles, and again, deciles divide the data into 10 groups. D1, D2, all the way to D9. So we're going to do an example with the IQR, and then we're going to talk about deciles. Now, what's the relationship between percentiles and deciles? D1 corresponds to P10, D2 to P20, and so on and so on. Q1 corresponds to the 25th percentile, Q2 to the 50th percentile, and so on. And so now we're going to be talking about how to use the IQR, the interquartile range. So an outlier is an extremely high or extremely low data point compared to the rest of the data values. But just because it seems like an outlier, we can't denote an outlier. We actually have to figure it out, calculate if indeed it is an outlier. So the first thing is that you arrange the data in order, and you find Q1 and Q3. Then you find the IQR. Then you multiply the IQR by 1.5. You subtract the value that you got by multiplying the IQR by 1.5. You subtract the value from Q1 and you add the value to Q3. And then you check the data set. So any value that is smaller than Q1 minus 1.5 IQR or larger than Q3 plus 1.5 IQR is indeed an outlier. So here we have the same data set. So we're going to go ahead and check for outliers. We know that Q1 is 9. We know that Q3 is 20. So then IQR would be just the difference, and that's going to be 11. So if we multiply the IQR by 1.5, we get 16.5. So now what we're going to do is we're going to subtract this from the Q1, and we're going to add it to Q3. So then we have negative 7.5 and 36.5. So any data points that are less than negative 7.5 or higher than 36.5 are in fact outliers. And the only data value that falls outside of that range is 50. So then 50 is in fact an outlier. And that's the end of lecture 10, unit 2. Thank you.